fractions, the basics, add or subtract, which may or may not require an LCD or least common denominator. All right? So let's review. A fraction consists of natural numbers in the numerator that's written above the fraction bar at the top. The denominator is written below or the bottom. So you have your fraction bar here, and then the top, the 2 and the 3 are numerators, the 7 and the 4 are denominators in our two fractions, 2/7 and 3/4. Natural numbers, remember, are counting numbers, 1, 2, 3, 4, 5. Do not include 0, that's whole numbers. Okay, that's a different set of numbers. Improper fraction, numerator is bigger than the denominator. So 19/4 is the same thing as that mixed number, 4 and 3/4. Okay, mixed numbers are a whole number added to a fraction without the addition sign. When you are performing operations in algebra, improper fractions are easier to deal with. So in my class, I'm going to want everything as an improper fraction unless the directions specifically state mixed number. If you're in somebody else's class, you need to find out what it is they want you to do. Okay? Because you're in their class, and you should do what they want you to do. Not what you want to do or what the guy on YouTube says, what you want to do. Oh, I'm sorry, what they want you to do. Combining, adding or subtracting fractions. So you will hear me say combine a lot. Combine fractions, combine like terms. When I say combine like that, I am referring to adding and subtracting. So here, the sum, which is add, or the difference, which is subtract, of two fractions. So the sum or difference of two fractions, here's a key component. With identical denominators is the sum or the difference of the numerators over the common denominator. So if you're adding them the sum, if you're subtracting them the difference. Okay, we add when the signs are the same, and we keep the sign. We subtract when the signs are different, and we take the sign of the larger number, irregardless of the sign. So if m over n and p over n are fractions, notice they're both over n, then m over n plus p, if you have a plus here, you add the numerators, but notice what happens. The denominator is n in each case. It does not change. Right? 1/2 plus 1/2 is 1 whole, right? 1/2 plus 1/2 is 1 whole. That's 2 over 2. The 2 in the bottom didn't change. The top, the numerators got added together. So if you subtract here, you subtract here. But again, the n doesn't change in the denominator. Right? Note, the denominator must be identical to add or subtract, which is combine fractions. The denominator must be identical to add or subtract, which is combine fractions. Here's a special note. If identical denominators are not given, then you must find the least common denominator, which is the LCD, before you add or subtract those fractions. Okay? You need to find the LCD before you add or subtract those fractions. If you have trouble finding the LCD, or you don't understand what I'm doing when I'm finding the LCD here, then you can watch my video, Least Common Denominator, LCD, the basics. Okay? So perform the indicated operation and simplify. So 5/17 plus 3/17. So the big idea here is what am I doing? I'm adding. When I add or subtract fractions, I must have an identical denominator, what's known as the common denominator. All right. Now, the least common denominator, again, we're going to find that if we need to, is going to be a common denominator, but the one that's simplified or reduced to lowest terms. Okay. So here, we have an identical denominator of 17. So that means that my denominator won't change. What am I going to do? 5 plus 3. This is what goes in the numerator at the top. Okay? So 5 plus 3 over 17. And what is 5 plus 3? It's 8 over what? Remember, when you add or subtract fractions, the denominator doesn't change. Now here, it could possibly change. Once you get it added or subtracted, then you go into simplify or reduce mode. So do 8 and 17 have anything in common? The answer is no, so you cannot simplify that or reduce it to lowest terms. It's already in lowest terms, so 8 over 17 is your final answer here. So what about 3 over 14 plus 1 over 14? Well, again, my denominators are identical, so I can have everything over what? 14. And then the numerator is this, 3 plus what? 3 plus 1, which is, what is 3 plus 1? 4 over 14. Do 4 and 14 have anything in common? Yes. What do they have in common? 2. So look, if we wanted to show it, we could say, okay, this is not 4. This is something times 2 over something times 2, and it's going to be 2 and 7, right? And then the 2's divide out. 2's divide out, and we're left with 2 7ths. Again, you could go from right here. You don't have to show all this if you don't want to. You could just go, hey, 2 and 7, right? 2 goes into that 2 times. That's 7 times, right? So, but I wanted to show it there. May show it another time or two and then may stop showing it. All right. You can also go back and watch my simplify, reduce fractions, the basics video, if you need help simplifying 4/14 down to 2/7. So 15 over 18 minus 7 over 18. Well, look, don't go look at that and go, hey, 15 over 18 simplifies. Let me divide something out. No. If they're already over an identical denominator, don't undo that, right? They're already both over 18. Don't undo that. So keep it all over 18 and then do 15 minus 7. Okay? 15 minus 7. And what is 15 minus 7? Well, it is 8 over 18. Is 8 over 18 simplified? No, because 8 and 18 both, what goes into both those? Well, at least a 2. They're both even, right? So let's go do that. Let's take a 2 out. Let's say this is going to be 4 times 2 over 9 times 2, right? And the 2's divide out, and I'm left with what? 4 over 9. Do 4 and 9 have anything in common? The answer is no, so you can't go any further. You're done with that one. So look at the next one. 1/5 plus 1/3. Now wait a minute. 1/5 plus 1/3. Do they have are those identical denominators? Nope. They're not. So again, if you need help with what I'm about to do here with the least common denominator, the LCD, I want you to go watch that video on the LCDs that I have. Okay? It will help you understand what I'm doing here and how to find them. So 1/5 plus 1/3, my LCD, I always start with the bigger one, 5. 5 is bigger than 3. Doesn't matter where the 5 is located, first fraction, second fraction, third fraction, whatever. You take the largest one. The largest denominator is 5. My other denominator is 3. You worry about all the other ones, but here there's only one other one, 3. So does 3 go into 5? And by go into, I mean divide into. And the answer is no. So then I take multiples of 5. So 5 times 2 is 10. 5 times 5, 10, 15, 20, 25, 30, 35, 40, right? So does 3 go into 10? That's the next one. No. What about 15? Yes. So I take multiples of the largest denominator, 5, until 3 goes into it, until all the other denominators do. In this case, the only other one was 3. So 15 is my LCD. So I'm going to rewrite this as something over 15 plus, nope, not going to do that yet. I'm going to rewrite this as 1/5, and I'm going to multiply it by something plus 1/3. I'm going to multiply that fraction by something to get 15 plus something over 15, okay? I want them to be identical denominators. So what is it I multiply right here to make it 15? Well, right? I need to do 5 times 3 because 5 times 3 gives me 15, doesn't it? So then if I put a 3 in the denominator, the bottom, I got to put a 3 in the top, the numerator. Because 3 over 3 simplifies to 1 and doesn't change, right? Doesn't change the value. This would be an equivalent fraction when I multiply that. And then over here, what do I multiply here to get 15? Well, I'm trying to get this 15, I guess. Okay? 3 times what? 5. And if I put a 5 in the bottom, I got to put a 5 in the top, right? Numerator over denominator. 5 over 5. Now, what is 1 times 3? I'm multiplying fractions. 1 times 3 is 3. 5 times 3 is 15, right? Here, 1 times 5 is what? 5. And then 3 times 5 is 15. So 3/15 plus 5/15. Now they're all over 15, and I'm going to do 3 plus 5, and that's what? 8 over 15. And does 8 over 15 simplify or reduce? The answer is no. There's nothing that divides into both 8 and 15. So 8/15 is reduced or simplified, reduced to lowest terms. Okay? So we had to find the LCD for that one. So let's look at 4/15 plus 2/5. What am I doing? I should have been asking that all along, and I think I've skipped it on some of them, right? Let's go back. What was I doing? I was subtracting and adding, right? And anytime I add or subtract, I've got to find or got to have a common denominator. So here I'm adding, right? I'm adding. So I must have a common denominator. Right? Must have a common denominator. So 4/15 plus 2/5. So my LCD, we start with the largest denominator, 15. and we ask ourselves, do all the other denominators, in this case the only other one is what? That's right, 5. Does 5 divide into 15? Yes, right? 5 times what? 5 times 3 is 15. It's perfect, right? Goes right into it. So my LCD is 15. So when I do that, 4 over 15, do I need to multiply 4 over 15 by anything? No, because 15 is already 15, right? If you already have the LCD, I don't need to multiply like I did, on both the fractions before. Here, plus this needs to become 15, right? So this one, 2/5 does need to get multiplied by something. Well, what do I multiply by 5 to get 15? Put it here, right? 3. So if I put 3 in the denominator, I got to put 3 in the numerator, right? So this is going to end up being 4 over 15 plus, and then I multiply. 2 times 3 is what? 6 over 5 times 3. The whole reason I did it was to get what? 15, right? I want identical denominators. And your LCD doesn't have to be 15. It just is on a couple of the ones I've done so far, right? So here, this is going to be 4 plus 6 over 15, which is 10 over 15. Am I done? No, I'm not done. Why am I not done? Because 10 and 15 have something in common. They have what in common? A 5, right? So this 5 goes into 10 twice, and 5 goes into 15, what, 3 times? So this becomes 2/3. Now, again, if we did this properly, 10 over 15 equals 2 times 5 over 3 times 5, and the 5's cross out, divide out, and you get 2/3. Okay? That's where that comes from, right? That's the actual work that goes into it. So if you want to say, okay, this is my little thought cloud down here, Mr. Guest, where I did that, that's fine. And by the way, if your teacher wants to see that work, you show it. I'm okay with my students telling me 10/15 is 2/3 in their head. I believe them if they tell me, Mr. Guest, I can divide 5 out of 10 and 5 out of 15 in my head. Okay? So, but I'm also dealing with problems that have much, much more work in them at the classes I teach. So I'm okay with that one step being done. If that's all you're doing, then you probably need to show your teacher that step, because that's what they're trying to check and see if you know how to do. But you make sure you know what they want you to do. 5/2 minus 2/5. So what am I doing? Well, subtracting. So if I subtract, I need a what? I need an LCD. Which one's bigger, 2 or 5? Aha, 5 is bigger, right? Does 2 go into 5? Nope. So then I do what? I take multiples of 5. 5, 10, 15, 20, 25, 30. What's the first multiple of 5 I get to that 2 goes into? That's right, 10. Right? 10. 5 times 2 is 10. 10 is my LCD. So then neither one of these are 10, so they both get multiplied by something. So 5/2 gets multiplied by something minus 2/5, and it also gets multiplied by a fraction, because I'm trying to get to the point where this is over 10 minus this is over 10, right? That's the point I'm trying to get to. I'm trying to get identical denominators. That's the entire point of least common denominator, LCD, okay? To add and subtract fractions, the denominators have to be identical. So here, what do I multiply by 2 to get 10? Well, the answer is 5, right? So if I put a 5 down here, I got to put a 5 up there, right? So now this first fraction, 5 times 5 is what? 25, and 2 times 5 is 10. So that's 25 over 10. And the next one, what do I multiply by 5 to get 10? 2. So a 2 down here, 2 up here. 2 times 2 is what? 4. And then 5 times 2 is what? 10. So now I have identical denominators, right? So I can rewrite this as everything over 10 is going to be 25 minus 4. And what's 25 minus 4? 21 over 10. Do 21 and 10 have anything in common? Any common factor? The answer is no. So 21 over 10 is in simplest form or simplified, okay? It's reduced to lowest terms. So 21 over 10. And again, that'll be 2 and 1/10 as a mixed number, but my class doesn't need to worry about that, but you may. If your instructor, teacher, professor wants that, you do that. They're your teacher. All right, 2/3 minus 5/6. So are my fractions, are my denominators identical? The answer is no. I don't have a common denominator right now, so I need one. My LCD, the biggest one is 6. Does 3 go into 6? And the answer is yes. So my LCD is 6. That's nice. So then if my LCD is already 6, then I say 2/3. Do I multiply that by something? Yes, because it's not already over 6. Minus 5/6. Do I multiply 5/6 by anything? The answer is no, because it's already over the LCD of 6, right? So then I go back and ask myself, okay, what do I multiply? And you can do this along the way. What do I multiply by 3 to get 6? The answer is 2. So put a 2 here and put whatever you put in the bottom, you got to put in the top, right? 2 over itself, numerator and denominator. Because what is 2 over 2? That's 1. If you multiply something by 1, you don't change the value of it, right? We're getting an equivalent fraction so that our denominators are identical. So then here I'm going to come in here and say, okay, this is going to be something over 6 minus, and I know that's 5 over 6. So 2 times 2 is what? 4. And 3 times 2 is 6. So 4/6 minus 5/6. So we're subtracting. So again, denominator doesn't change. 4 minus 5. How do I subtract 4 minus 5? I get negative 1 over 6. Now, technically, that's just fine. Negative 1 over 6 is just fine, right? And in some of my classes, I'll even accept that. Typically speaking, if you have a single term 1 or negative 1 over a single term 6, and there is one negative sign involved, right? What is a negative divided by a positive? It's negative. So we typically write this with a negative out front. Negative 1/6, okay? I'm going to go ahead and box that because that's a legitimate answer. But again, in a lot of my classes, I'll take either. Sometimes I require you to put it out front just because I'm being mean, right? You need to make sure you know what your instructor or professor or teacher wants. If they want you to put that negative out front, then by all means, you better do it. You better understand when you do it and when you don't. It's when it's one term. It means no pluses or minuses except for that leading negative. That's a leading, right? It wasn't negative 1 plus x or x minus 1. That's not a leading. X minus 1 is not a leading negative. So here, one term over one term, that negative comes out front. So look at the next one. 9/14 minus 2/14. Are they identical? Glory, hallelujah, yes, right? That means this is going to be over 14, and it's going to be what? 9 minus 2. Well, what is 9 minus 2? It's 7 over 14. Am I done? The answer is no, right? Because 7 and 14 have something in common. What goes into both 7 and 14? 7 does, right? 7 goes into 7 once and 14 twice. So this becomes what? 1/2. That becomes 1/2. And that is now simplified. You cannot do anything else to that. It's reduced to lowest terms. All right. One more. This time we are doing what? We are adding and subtracting on the same problem, but it doesn't matter. As long as we add or subtract, we have to find a common denominator. So just because we're doing both, we still got to find a common denominator. So that means I need to find my LCD, okay? And my biggest one, which one of these is the biggest? 6, right? So we always start with the largest one, and we ask ourselves, this time, what are my other denominators? I have a 2 and a 3, right? Does 2 divide into 6? Yes. Does 3 divide into 6? Yes. If either one of those had been no, I would have done the multiple thing, right? But here, they both divide into 6. So guess what my LCD is? It's 6. So when I get ready to do this, I have 1/2, and I have to multiply that by something because I want this to be 6 down here, right? And then plus 2/3, and again, that's not 6, so multiply by something, minus 5/6. This is already 6, so don't multiply it by anything, okay? So what about this first one? What do I multiply by 2 right here to get, not to get 2, to get 6, okay? And the answer is 3, so put 3 over 3. And then what about this one? 3 times what gives me 6? Well, 3 times 2, right? And that's already 6, so we don't multiply by anything. So whatever I put in the denominator here, 2, put it over 2 there, right? Left that 2 off there. So now we come in here and we say, okay, this is going to be over 6 plus something over 6 minus, and we know this is 5/6 already. Multiply 1 times 3 is what? 3. And then 2 times 2 with a positive out front is what? Plus what? Plus 4. Now everything is over 6, so we're going to keep this. Let's just keep coming down here. Keep this over 6, and we're going to have 3 plus 4 minus 5. So I'm going to put these first two together right here, and I'm going to get 7, right? It's going to be 7 minus 5 over 6. Is that right? 3 plus 4 is 7. 7 minus 5 is the next thing, right? So what is 7 minus 5? 2 over 6. And then, do they have anything in common? 2 goes into 2 once, and 3 goes into 6 3 times. So then that thing simplifies. Just because I added all that up and subtracted all that in the numerator and got, 2, and I was 2 over 6, I'm done. No, you're not. You got to check to see if it is in lowest terms. And it was not. So you had to simplify it to 1/3. Okay? So that one was sort of a big boy problem, right? It had 3 fractions in it. And they weren't big numbers, but you still had to multiply 2 of the fractions by something to get the LCD, or to get the fractions in equivalent form with the same denominator. And then you had to combine like terms in the numerator, which was multiple steps. And then when you got there, you got 2/6 and said, hey, wait a minute, 2 and 6 have a 2 in common, so it can simplify or reduce to lowest terms. So the final answer here is 1/3.